trying to identify sources of interference on satellite, microwave backhaul, or even cellular and land mobile radio systems is one of the most tedious and time-consuming tasks, especially if the interfering signal is intermittent. It frequently requires monitoring the RF spectrum over a long period of time to try and identify the frequency and location of illegal transmitters, jamming signals, and transmitters that are emitting signals outside of their authorized frequency band. It's even helpful doing long-term spectrum logging when trying to identify unoccupied sections of RF spectrum for spectrum management planning. This is where the interference analyzer and spectrogram option on the FieldFox is invaluable. Not only does it log and record the spectrum trace over a period of time, which we can play back and analyze later, but with the built-in GPS receiver, it can also record the time, elevation, date and GPS position as we drive around. Here we've got a couple of spread spectrum signals and a couple of smaller spread spectrum signals and some narrow band modulated signals or carriers of varying amplitude. But over here you'll see we've got an intermittent signal. Let's turn on the spectrogram. If I press the measure button and then interference analysis and select spectrogram, you'll see we've still got the spectrum trace on the display, but also at the bottom of the screen we've got a spectrogram picture forming. Now I'm going to adjust the display slightly. I'll press Mesh Setup, Spectrogram Settings, and I'll change the spectrogram view to top. So I've got the spectrogram at the top of the screen and the live spectrum analyzer trace on the bottom half. And I'm going to adjust the color limits of the spectrogram. I'll adjust the lower level blue limit and the red limit. And now on the spectrogram display, you can see that the broad spread spectrum signals that are there continuously show up as a continuous colored bar on the spectrogram trace. The red color indicates a strong signal and the blue color indicates a weak signal. Here are the narrowband signals we saw previously, fairly weak. But here on the left now, we can easily capture an intermittent signal. And of course I can press the marker button, and turning on that marker, we can move that across and measure at what frequency that signal is. And of course we can save the screen image onto our USB memory stick or SD card. Now if I press the measure button again, and interference analysis, the other useful display for identifying intermittent or interfering signals is the waterfall display. This is like a three-dimensional view of the RF spectrum. The bright yellow trace is the current live spectrum analyzer trace, and the colored traces behind that are a history of all the previous spectrum traces that we've seen. Now, whether you prefer the waterfall display or the spectrogram display probably comes down to personal preference, but they certainly provide an invaluable additional method of identifying intermittent interfering signals. The spectrogram and waterfall displays are perfect if we want to sit in front of the FieldFox and visually identify signals of interest. But what if we want to leave the analyzer monitoring the spectrum over a longer period of time, perhaps overnight or over a weekend? Well, that's where we can use the extremely sophisticated record and playback capabilities of the FieldFox. Without the need for a PC, we can tell the FieldFox to record the RF spectrum over a predefined interval with a user-defined capture interval, and each trace is time and date stamped with a GPS position and elevation as well. Ideal if we want to perform spectrum recording while mobile and record our position. So let's press interference analysis and turn the spectrogram off. You'll see I've plugged in an external GPS antenna, and if I press System Configuration and GPS, you'll see I've turned the internal GPS receiver on. The latitude, longitude and elevation are all being measured. And here I've got the GPS lat and long information display turned on, so that information bar will be visible when we're in normal spectrum analysis mode, but if for security reasons you want that turned off, you can. And now if I press the trace button, you'll see there's a green button here called Record and Playback Setup. So I'll press that. So I've got my storage device set to internal. I could obviously set that to a USB memory stick or the SD card, but for now I'll store all the Spectrum traces into the internal memory. And we'll create a new recording session. And if I press the recording configuration, here you can set under the record time the maximum amount of recording time that you want to record for. With the record time set to max, it'll keep recording Spectrum traces until the memory is full. I'll leave it at that for now, but you could put a time limit on it if you wish. The record source I've got set to raw measurements. Alternatively, you could select one of the traces, which you might have set to max hold, for example. The record interval I've got currently set to minimum. That means that the Spectrum traces will sweep and record as fast as possible. But for example, if I set that to an interval of 60 seconds, it would hold off a minute between each Spectrum trace being recorded, and we can go up to 10,000 seconds, which is an interval of approximately 3 hours. And one final feature I'll just mention here is the frequency mask trigger capability. With the frequency mask trigger, we're able to create a set of limit lines or threshold lines across the display so that, for example, if we only want to capture this trace when this intermittent signal occurs, we can set an amplitude threshold line here just between certain frequency limits, and whenever that threshold is exceeded, the analyzer will trigger and capture the traces while that signal is visible. It makes more efficient use of your storage device, your USB or SD card storage device, because you're not filling it with Spectrum traces that aren't of interest. Okay, we'll press back and let's record. So you can see here now we recorded 6, 7, 8, 9, 10 traces, the time and date, and of course the GPS position is being recorded as well. Now while that's recording, at any time I can press the pause button. Recording is now paused, but the Spectrum trace is still live, so I can still monitor the trace looking for a signal of interest, and if it occurs, I can press the pause resume button again, and we're now recording those traces. Another useful feature is the user tag button. I can press that at any time I like, and it automatically adds a user tag to that current trace in the recording. So for example, if we're driving around and we enter a tunnel, I could press the user tag as we enter the tunnel and again as we leave, and that'll perhaps give me a prompt when I'm reviewing the Spectrum trace later that maybe something happened during our journey there, and I should be aware of that fact. Okay, we've captured 160 traces. I'll press stop and let's press play. So the analyzer is now playing back those 162 traces at super fast speed, which is a great way of reviewing what happened in a much shorter space of time. But interestingly, of course, I can still press pause even in playback mode, and now I'm viewing trace number 27. I can manually scroll through each trace. So here I can select trace 29, which has that intermittent signal present, and analyze that, save that screen capture, of course, as a picture for including in a report or emailing to someone, and then step further forward through looking at the rest of the captured Spectrum data. Not only are the Spectrum traces stored to a log file in the internal memory, as I've been using here, a USB memory stick or an SD memory card, but as always with the FieldFox, we can save the screen image and of course the complete instrument setup into a state file that we can recall later if we want to repeat the same measurement at a different location. For further information on the FieldFox Microwave Analyzer, please contact your local representative or visit the website shown below.